Hey everybody, welcome back again. We are in nuclear chemistry, and what I have for you is a few nuclear decay reactions, and I'm going to go over the particles briefly like we did in class. You get your 4,2 helium nucleus, which is an alpha particle. Remember, it has 2 protons and 2 neutrons to give you a total mass of 4, total charge of 2. You have your beta particle, which is basically an electron that is fabricated in the nucleus. So it has a mass of 0 and a charge of -1. Then you have your positron, which is another particle fabricated in the nucleus, and it has a mass of 0 and a charge of +1. That's why it's called positron, because it's basically a positively charged electron. Down here you have your normal 3 subatomic particles that we've dealt with for about 2 months now. You have your protons, mass of 1 and a +1 charge. Your neutron, mass of 1 with a 0 charge, and your electron, mass of 0 with a -1 charge. So in order to properly balance these nuclear decay reactions, you just have to make sure that everything to the left side of the arrow, which is called a reactant, is balanced with everything to the right side of the arrow, which is a product. So make sure you balance your reactants and your products. Remember, we went over that. That's the law of the conservation of mass. So if you do that, you look at this first problem. We have potassium with a mass of 42 and a atomic number of 19, and we're going to balance it out to the right side to see what it decays into. Remember, this is nuclear decay, so these are radioactive isotopes that need to relieve themselves of some energy, so they're going to emit particles from their nucleus in order to do that. So the potassium 42 atom will emit an electron, and if it does that, you have a mass of 0 ejected. So in order to equal your mass on the left, which your original radioactive isotope is, you have to have 42 right here. See what I'm saying? 0 plus something equals 42. So that mass is going to be 42. We lost no mass. When you emit that electron, it loses 0 mass out of its atom. Now what you do lose, you have a -1 charge. So what happens is, you had 19 for your atomic number already. If you have a -1 right here, something has to be added to that -1 for the law of conservation of mass to balance out on both sides. So what plus -1 would equal 19? The answer is 20. 20 plus -1 equals 19. 42 plus 0 equals 42. So 42 and 20 is your new element that is created through this decay. And if you look on your periodic table, atomic number 20 is calcium. So potassium 42 decays into calcium 42. All right, the next one down the line is plutonium. We have a plutonium 239. It decays by emitting an alpha particle from its nucleus and then becomes something else. So let's do the same thing. You balance everything on each side of the equation. So 239 is your mass on the left side, where the reactants are. So then on the right side, you have to have 239 for mass for your products. So what plus 4 equals 239? And it's 235. Then, look at your atomic numbers. You have an atomic number of 94 for plutonium. Your alpha particle has an atomic number of 2. So what plus 2 equals 94? 92. So you look on your periodic table, and element number 92 is uranium. So plutonium, through alpha decay, becomes uranium. And last, we have something we don't know. It's a radioactive isotope that's going to decay into thorium. And it used an alpha particle for this decay. So it emitted an alpha particle from its nucleus. So let's look at the mass on the right side of the equation. You have an alpha particle with a mass of 4. You have thorium with a mass of 231. So 231 plus 4 equals 235. So your mass for the decaying element must be 235. Then, look at your atomic number for the alpha particle is 2. The atomic number for thorium is 90. So 90 plus 2 is 92. So then you have an element with a mass of 235 and an atomic number of 92, and that is uranium. So you see here, plutonium alpha decayed into uranium. Uranium can in turn alpha decay into thorium, and it just goes on down the line until it finds its most stable energy level. So anyway, I hope this helps with your nuclear decay, balancing nuclear reactions, and good luck on your test.